Hi viewers, so welcome back to the channel. So in this video we are going to continue the problems related to finding out volumes of combination of solids, right? So in the previous video till problem number 4 we have discussed. So in this video we are going to discuss about problem number 5, right? So what is given? So in the adjacent figure, so here a cylinder is given and the height of the cylinder is 10 centimeters and the diameter is 7 centimeters, and from this two equal conical holes of radius 3 centimeters and height 4 centimeters are cut off as shown in the figure. So here we are removing two cones, right? Then what is he asking you to find? So volume of the remaining solid. So by reading the question you might have understood so what we need to do, right? So if I want to find out the volume of remaining solid, what should I do? So I need to remove those two conical volumes from the volume of cylinder, right? So that's it. So that is what the thing that we need to find here, right? Now first of all we are going to take the considerations. So what are the things that are given? So first thing is height of cylinder is given. So height of cylinder how much? So it is given as 10 centimeters. The same way diameter of cylinder is given as 7 centimeters. So while writing, so write it clearly. So diameter of cylinder is 7 centimeters. So from this clearly radius of cylinder is given as 7 by 2 centimeters. Okay, after this, so what we need to find? So we need to consider the terms of cone, no? So height of cone. So what is height of cone given? So height of cone is given as 4 centimeters and radius of cone is given as 3 centimeters. So these all are the things that are given here, right? Now what I need to find? So volume of remaining solid. So volume of remaining solid is given by, so from the figure we can simply say that, so from volume of cylinder if we remove 2 times of volume of cone, so then we are going to get the remaining volume, right? So from this directly, what is volume of cylinder? So volume of cylinder is pi r square h. So since this is about cylinder, so we are going to consider with suffix cy minus, so 2 into what is volume of cone? So volume of cone is 1/3 pi r square h, no? So here r square of cone into height of cone. Now when I substitute the values, so what I am going to get? So this is 22 by 7 into what is radius of cylinder? So radius of cylinder is given as 7 by 2. So this is 7 by 2 into 7 by 2 into height of cylinder is 10 by 1 minus, so this is 2 into 1 by 3, which I can write it as 2 by 3 into pi value is 22 by 7 into what is the radius of cone? So radius of cone is 3 centimeters. So 3 by 1 into 3 by 1 into, so what is height of cone? So height of cone is given as 4. So 4 by 1. Now on simplification, so this 2 gets cancelled. Next this 2 in 22 it goes 11 times. So finally, so what I am going to get here? So 11 7s are 77, 77 10s are 770. So what is the half of 770? So this is nothing but 770 by 2 minus, so here, so this 3 will cancel 3 times, sorry, with this 3. Next we are left with nothing here, right? So 22 by 7. So is there any cancellation for 7 here? So there is no possibility for cancellation with 7. So that 7 will be remain in the denominator, right? Now multiplication. So 22. So 2 3 6 6 4 is 24. 24 22s. So 24 into 22. So 4 2s, 2 4s are 8. 2 2s are 4. The same way 48. Then what I am going to get? So 12. So 528. Then what I am going to get here? So 528 divided by 7. Now if I divide with the 2, so 2 3s are 6. So 17. So 17 means 2 8s are 16. So 1. So it gives me 385 minus in 7 table. 7 7s are 49. So 49 means I will be left with 3, 38. So 38 means, so 7 5s are 35 again. So 3 will be left 30. That means so you will be left with 4. So 7 4s are 28. So again I am going to get 20. So 20 means, so 7 2s are 14. So I need to subtract this. So what I am going to get? So 385.00 minus 75.42. Now when I subtract this, so what I am going to get? 10 minus 2, 8. 9 minus 4 is 5 point. So here 14 minus 7. Sorry, 14 minus 5 is nothing but 9. Here 7 minus 7 is 0. So 309.58. So the answer is 309.58 centimeter cube. So since this is volume, so we are going to get the units as centimeter cube. So this is nothing but the volume of this particular remaining solid, right? Next, moving on to one more question. So what is the given question? So there is a spherical marble. So there are spherical marbles of diameter 1.4 centimeters that are dropped into a cylindrical beaker of diameter 7 centimeters which contains some water. Right? So he did not say it is filled with water, so it is containing some water. So find the number of marbles that should be dropped into the beaker so that the water level rises by 5.6 centimeters. So have you understood the question? So in the previous video, so we have discussed the amount of water that is spilled out of that particular water tub is nothing but given by the volume of solid that is inserted inside it, right? The same way here also, since we need to drop marbles, right? So marbles are to be dropped into the cylindrical beaker so that water rises by 5.6 centimeters, right? Now if you observe, so the level of water is obtained by means of the beaker. So here the beaker is, so the given beaker is in the form of a cylinder, right? So the water rising also will be done in the same shape, right? So here this is my cylindrical beaker. So in this cylindrical beaker, for suppose I am having water till here, right? So I am considering this water as, so till here, and after that what is happening here? So when I drop marbles, so marbles all are spherical in shape, so when I drop into it, the water should rise to a level of 5.6 centimeters. That means this level should be 5.6 centimeters. So for suppose, right? So this amount of rise should be there. So since the beaker is in cylindrical shape, that means this 5.6 is nothing but height of that particular cylinder only, no? Right? So that particular cylindrical shape volume gets increased. That means, so this particular increase, so whatever the increase that we got here, this increase is all because of those spherical marbles, right? So what we can say indirectly here, so the volume of those spherical marbles, the volume of those spherical marbles is nothing but the volume of this particular cylinder which is having height 5.6 centimeters, right? Now simply what I can say, so first of all we are going to write, so you got an idea, I think, right? So all these marbles volume will be equal to the volume of this particular rise in level. Okay, so from this, so first of all we are going to write, so what are the things that are given? So diameter of spheres, so diameter of sphere is given as 1.4 centimeters. So with this I can write it as 14 by 10 centimeters. So clearly, so from this radius of sphere is given by, so 7 by 10 centimeters. Next, what are the things that are given about cylinder beaker? So cylindrical beaker, so diameter of cylinder is 7 centimeters. So clearly from this radius of cylinder is 7 by 2 centimeters. Next, he has given that for suppose if water is at an height of some h centimeters, right? So I am going to consider this as height of that particular centimeters. So h centimeters, let for suppose my initial height of water is. Next, after adding the marbles, what happened? So my height increased by 5.6 centimeters. So by means already h is there, so for that 5.6 centimeters I got an increase, right? Now from this what I can say, so what would be the relation? So what is the relation that I can relate here? So first of all, here there is some volume of water which is having height h. So to that volume, if I add spherical marbles, then I am going to get some more, right? So from this what I can say, so volume of cylinder with height h plus, so volume of cylinder with height h plus volume of cylinder, or simply what we can say here, so no need of getting confused. So here what I can say, volume of cylinder with height 5.6 centimeters. So this particular volume is obtained because of those n spheres only, no? So since we don't know how many spheres we have dropped, so what I am going to get, so n into volume of spheres, so volume of each sphere, right? So here n is nothing but number of spherical balls that I have dropped. Understood? So here this particular 5.6 rise is because of these n spherical balls. So from this directly what is the formula? So volume of cylinder, so pi into r square h is equal to n into, so volume of sphere is 4/3 pi r cube. Now here this is nothing but height of cylinder, this is radius of cylinder, and this is radius of sphere. Now on both sides I can cancel out this pi and pi. Now substituting the values, what is radius of cylinder? So radius of cylinder is 7/2. So this gives me 7/2 into 7/2. And what is the height of cylinder? So this height of cylinder is nothing but this 5.6, because that is nothing but the rise, right? So this 5.6 I can write it as 56/10 for my convenience, right? Is equal to n/1 into 4/3 into what is radius of sphere? So radius of sphere already we know 7/10, right? So 7/10 whole cube. Now since I need the value of n, so I am taking n as subject and I am going to transpose all these things to the other side. Then from this what I can say, 7/2 into 7/2 into 56/10 into, so this 4/3 becomes 3 divided by 4 into, this becomes 10/7 into 10/7 into 10/7. Now on simplification, so 2 7s are, so 2 7s get cancelled directly. Next 7 8s are 56, right? So 7 4 2s, so 7 into 4 into 2, so 7 4s are 28, 28 2s 56. So directly I can cancel it. Now what I am left with, so 110 I can cancel it out. Now directly in the numerator what I am having, so this is 300, so 300 divided by 2, so 300 divided by 2 is nothing but 150. So directly what I can say here, if I drop 150 spheres, so if I drop 150 spheres, the height of the water level rises by 5.6 centimeters, right? So how many I need to drop? So totally 150 spheres I need to drop so that water level rises by 5.6 centimeters, right? So this is a simple problem. Right, next moving on to one more question. So this is nothing but a question. So there is a pen stand. So pen stand is made up of wood in the shape of a cuboid. So already the pen stand is in the shape of a cuboid, and to keep the pens, so what he did 3 conical depressions. He made 3 conical depressions. Next, the dimensions of the cuboid are given, and the radius of each of the depression is also given, and the depth of the depression is also given. What is he asking you to find out? Find the volume of the wood in the entire stand. That means after removing those depressions, so after removing all those 3 conical holes, so what will be the volume of the remaining wood stand, right? So let us see this. So first of all, what are the things that are given? So about cuboid, so length of cuboid is given as 15 centimeters, breadth of cuboid is given as 10 centimeters, and height of cuboid is given as 3.5 centimeters. So this 3.5 centimeters I can write it as 7/2 centimeters. So these all are nothing but related to cuboid. Next, about cone. So about the cone, what are the details that are given? So for that he has given radius of cone, right? So radius of cone is 0.5 centimeters. So this 0.5 centimeter I can read as half centimeter. And next, depth is nothing but height of cone only, no? It is nothing but 1.4 centimeter. So this 1.4 centimeter I can write it as 14/10 centimeters. So I got all the details. Now what is he asking you to find? So find the volume of the wood in the entire stand. So stand is obtained only after removing those three conical portions, right? So from this directly what I can say? So volume of stand is equal to what I can say? So volume of cuboid minus 3 times of volume of each cone. So what I can say? Volume of cuboid minus 3 times of volume of cone. So what is volume of cuboid? L into B into H minus 3 times of volume of cone is nothing but 1/3 pi r square H. Okay, so this 3 gets cancelled. Now substituting the values. So what I am going to get here? So 15 into 10 into 7/2. So this is one product minus here what I am going to get? 22/7 into, so what is the radius of cone? So radius of cone is half, right? So 1/2 into 1/2 into what is height of cone? Height of cone is 14/10. Now do simplifications. So what are the cancellations that are possible? So 7 2s are 14, right? Next, into table this goes 11 times. Now what I am left with here? So here, so into table this goes 5 times. So 15 5s are, so what is 15 5s? So 15 5s 75. So 75 7s are, so 75 into 7. So what I am going to get? 7 5s are 35. So 3 is remained. 7 7s are 49. 49 plus 3 52. So this is nothing but 525 minus 11/10 is nothing but 1.1. So 525 minus 1.1. So here what I can do? I am going to consider 525.0. So from that I need to remove 1.1. So 10 minus 1 is 9. Here 4 minus 1 is 3. So 523.9. So what is the answer? So 523.9 centimeter cube. So this is nothing but the volume of stand after removing those depressions, right? So the answer is 523.9 centimeter cube. So likewise we can find out volume of this particular stand, because here we are digging out the depressions. So since we are removing, so we have subtracted, right? Next, moving on to one more question. See, these are nothing but small questions, right? So a solid toy is in the shape of, in the form of a right circular cylinder with, so already you can see the shapes. So from the figure you can understand easily, right? So he has given, so one end is stuck with hemispherical shape and other end is with a cone, right? Their common diameter is 4.2 centimeters. Their common diameter. So common diameter means all are having the same radius. So from this what I can say? Radius of hemisphere is equal to radius of cylinder is equal to radius of cone. So directly I am going to consider radius. So which is nothing but, so what is half of 4.2? It is nothing but 2.1 centimeters. So 2 centimeters can be written as 21/10 centimeters. So this is nothing but radius of these particular three things. Next, what he has given? height of cylindrical portion is 12 and conical portion is 7. So since he mentioned respectively, so you need to take it in order, right? So what is that? Height of cylinder. So height of cylinder is 12 centimeters and height of cone is 7 centimeters. So these are all the things that he has given. He is asking you to find the volume of the solid toy. Use pi is equal to 22/7. Now directly, so volume of toy. So volume of toy is nothing but what we can say, volume of hemisphere plus volume of cylinder plus volume of cone, right? So these are nothing but these three volumes I need to consider here. So volume of hemisphere, so what is it? 2/3 pi r cube plus volume of cylinder is pi r square h plus volume of cone is 1/3 pi r square h, right? So here these are nothing but say about cylinders. So this is cone, remaining all radius are nothing but the same things, right? So from this what I can take common? So directly writing the values, 2/3 into 22/7 into what is the radius? So radius of all the things is 21/10, no? So 21/10 into 21/10 into 21/10 plus here 22/7 into radius again 21/10 into 21/10 into what is height of cylinder? So height of cylinder, so substitute the correct value. So if not, then you are going to get wrong answer. So 1/3 into 22/7 into what is radius? So radius is 21/10 into 21/10 into what is height of cone? So height of cone is 7 centimeters. So 7/1. So from this what I can do? So 7 3s are 21, I can cancel out. So here 7 3s 21, here also 7 3s are, so 121 I can cancel out. So in all the denominators, so we are going to have tens. So tens, so directly I can multiply the numerators. So 21 21s are 441, here 2 22s are 44. So 444 into 41. So if I multiply, what I am going to get? The same way here also we are going to do the multiplications. So on simplifications, so what we are going to get? So what we are going to get? So 441. So first one 441 into 44. So 4 4s are 16, 1 is carried. So 4 4 16, 117. The same way again I am going to get 1764. So from this 4 6 4 10. So 7 7 14. So 1 will be carried, 7 1 7. So 7 plus 8 1 plus 1 9. So 19404. So 19404 divided by 1000, no? So I can write it as 19.404 plus here when I do multiplication, so 22 3s, so 22 3s are 66. So 66 into 21 into 12. So 66 into 21. So 66 into 21. So 1 6 are 6. So 1 6 are 6. So 2 6 are 12. So 2 6 are 12, 13. So what I am going to get? 6 8 3 1. So 1386. So after getting 1386, so we need to multiply with again 12, no? So when I multiply with the 12, what I am going to get? 6 2s are, so 12 6 are 72, 7 is carried. So 12 8s are 96. So 96 103. So 10, so 103. So 10 is carried. So 12 3s 36 46. So 46 means 6 will be there, 4 will be carried. 12 1s are 12, 12 plus 4 16. So here since we are having two tens here, so I can write it as 166.32 plus here, so 22 into 21 into 7. So 22 7s are 154, no? So 22 7s 154. So 154 multiplied by 21. So 4 1s are 4. So 154. Next 2 4s are 8. 2 5s are 10. So 1 will be carried. 2 1s are 2 3. So 4 8 plus 5 is 13. So 2 3. Here also what I am going to get 32.34 because I am having 2 tens here. Now I need to add all these things. So if I add all these things, so 19.404 plus 166.32 plus 32.34. So when I add all these things, so what I am going to get? So let's see. So 166.32. Next, so 320 I am going to consider. Next 32.340. Next 19.404. So when I add all these, so here I am going to 6. So 437 plus 2 10. So 1 is carried. So 9 plus 1 10. 10 plus 8 18. So 1 is carried again. 6 plus 3 9 plus 10 11. So 1 is carried. So 1 plus 1. So what I am going to get? So I am going to get, so here, so there is no carry, so there is no 1 here, right? So this 1 will be carried here, so this becomes 218.064. so what is the answer? 218.064. since it is volume, so centimeter cube. So the answer is 218.064 centimeter cube. So likewise we can find out the volume of the solid toy, right? So thank you for watching the video. So in the next video we are going to do some more problems related to this concept. Okay, thank you for watching.